Lesson 7.1, Ratios and Similar Polygons. The objectives of this lesson are to identify similar polygons and apply those properties to solve problems. The vocabulary words are similar, similar polygons, and similarity ratio. Figures that are similar, and we use the little tilde sign to show similarity, have the same shape but not necessarily the same size. For example, in this set, triangle 1 and triangle 2 are similar. If you notice, they have the same shape and their angles appear to be congruent. We'll find out later that they must be congruent, even if the side lengths are different. But if you look in 1 and 3, triangle 1 is not the same shape as triangle 3, so they are not similar. Two polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So if we look at ABCD and EFGH, we notice that we have corresponding angles congruent. A and E are congruent. D and H are congruent. C and G are congruent. And B and F are congruent. If we make a proportion of each of the side lengths, we find out that they all will reduce down to being 1/2. ABCD is similar to EFGH, and in fact, it has a scale ratio or a similarity ratio of 1:2. EFGH is twice the size of ABCD. Let's look at an example. Identify the pairs of congruent angles and corresponding sides. So in this one, we are just trying to describe similar polygons. Angle N and Q are congruent, and angle P and R are congruent. And we know this because the two drawings show us that this is true. By the third angles theorem, we know that angle M is congruent to angle T. And if we look at the proportion of the side lengths, we find that they all will equal 2 because MNP is twice the size of QTR. A similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. Take note that in the first statement, the similarity ratio of ABC to DEF is 3:6 or 1/2. Make sure that when you make a similarity ratio that you put the right number as your numerator and the correct one as your denominator based on the order they are listed. ABC comes first, therefore it is the numerator. And DEF is 6, and that is on the bottom or in the denominator. You want to take any fraction that you have when you're making ratios and reduce it down to simplest terms, 1/2. If we compare DEF to ABC, we get 6/3 or 2 because DEF is 2 times the size of ABC. Writing a similarity statement is like writing a congruent statement. We need to list all the corresponding vertices in the same order, and you use the little tilde sign instead of a congruent sign. If we want to identify similar polygons, we have to determine whether they're similar or not. And then we write a similarity ratio and statement. So we are given rectangles ABCD and EFGH. The step 1 in determining if two polygons are similar is to identify the pairs of congruent angles. All angles of rectangles are right angles and are congruent. So we know that A is congruent to E, B is congruent to F, C is congruent to G, and D is congruent to H. Step 2 then will be comparing the corresponding sides. And when we say compare, then we mean the ratio. So AB to EF is 6:4, which reduces to be 3/2. BC to FG is 9/6, which is also 3/2. CD equals AB because opposite sides of rectangles are congruent, and GH is equal to EF. So we also get 3/2 for the ratio there and for the remaining two sides. Thus, we get the similarity ratio is 3/2 or 3:2, and rectangle ABCD is similar to rectangle EFGH. Let's look at another one. Determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. And we're given triangle PQR and triangle STW. Step 1, identify pairs of congruent angles. It's an isosceles triangle, so that means that P is congruent to R and S is congruent to W. Step 2, we're going to compare the corresponding angles. So measure of angle P equals measure of angle R, which is 1/2 180 degrees minus 36, which would be 72 degrees. The measure of W and S are 62 degrees. The measure of angle T is 56. And not one single pair of angles from one triangle to the other are congruent, so automatically the triangles are not similar. We don't have to go on to compare sides if the angles are not congruent. Let's look at a hobby application. Find the length of the model to the nearest tenth of a centimeter. Let X be the length of the model in centimeters, and the rectangular model of the racing car is similar to the rectangular racing car, so the corresponding lengths will be proportional. We then make ratios with the length of the racing car over the length of the model, and the width of the racing car over the width of the model. So we have 5 over X equals 1.8 over 6.3. We take the cross products property and multiply, simplify, and we get 31.5 equals 1.8 times X. If we divide both sides by 1.8, we get 17.5 equals X. The length of the model is 17.5 centimeters. Now you try. Identify the pairs of congruent angles and corresponding sides. Then determine if the polygons are similar and write a similarity statement and ratio. And then there are some other problems for you to solve using proportions.